Hi Ashley, here's one of the ones that you got actually partially correct. It was, I think, maybe 10 expressions and you had to categorize them, drag and drop them into either being rational or irrational numbers. So you had said this one was irrational, and an irrational is usually any square root that you can't get an exact answer to. A rational number is any number that can be written as a fraction. So it's almost like every whole number, or it is every whole number, every fraction, every decimal, as long as it's not a decimal that goes on forever without a pattern. Repeating decimals are, in fact, rational, but like a decimal like pi would be irrational. So this expression, if we look at the square root of 9, that can be simplified to be 3, and then it's 3 times 3/7, which, if we put that over 1, that would become 9/7. That's a rational number. It can be simplified. There's no more radical. So we're done with it. Another expression in that problem was this one that you also said was irrational. But we have these two square roots. So if we think back to, I think it's 6.2, the product property, we can find the product of these two. 5 times 5 is 25. So if we write that under the radical, that's what those two would simplify to be, and then we just bring down the 2. Well, we can simplify the square root of 25 to be 5, and then 5 times 2 is 10. So that answer is also rational. So you got most of that correct, because I think, again, there were like 8 expressions. There were 10 expressions. You got 8 of them correct. Just those two ended up also being rational. The next one was number 5, and what you did was correct. It just wasn't simplified. Whoops, I kind of wrote it wrong. All the way. So the original problem was 3 to the 4th times x times 3 over x squared. Okay, that was the original problem. You knew to distribute the exponent to both the numerator and denominator. And I'm pretty sure you got that, because then you also knew, negative exponents have to be made positive. So you wrote it, I think you wrote it like that, and then you just brought everything else down. So that, let me just make more room. That is correct, what you did. It just, like I said, needs to be simplified more. I know, you did simplify this part. 3 to the 4th, you did put 81. So that's right. But we have this x and that x. So again, using our properties of exponents, same base, we can just add the exponents. That exponent's really a 1. So x to the 1st and x to the 4th is really x to the 5th. And we can simplify this denominator. It's 3 squared. So I'm actually going to write it over here just to show you that 3 to the 4th was 81. We had the x, and then we had times x to the 4th. So I'm going to simplify this right here to be 9. So we can think of this all as fractions. So when I combine my numerators, that's where I got the 81 x to the 5th. I'm running out of board space. I don't know if you can read that, but that's 81 x to the 5th all over 9. Well, what can be simplified here is 81 divided by 9. 81 divided by 9 is just 9, and then we bring down the x to the 5th. So that would be the final simplified answer. So again, you got on your way, just need to do a couple more steps. Another one was the one I gave you the formula for, finding the area of, I think, a rectangular pyramid maybe. I gave one measurement was this, another measurement was 81 1/4, another measurement was 243 to 2/5. So the formula is to multiply all those together and then divide by 3. So I think you did get this all multiplied correctly and had like 729. You got it wrong because the formula says to multiply them together and divide by 3, like I said. So just to make sure you are understanding, whatever my denominator is, that's my root. And then I'm going to take that all to the 3rd power, whatever my numerator is. denominator is my root. Take it all to the, oops, not the fourth power, whatever my numerator is, 1. And this one, 5th root of 243, all to the second power, because that's my numerator. All right, the square root of 9 is 3, and 3 cubed, 3 times 3 is 9, 9 times 3 is 27. The 4th root of 81 is 3, so I'm just going to end up having to multiply that by the first answer. The 5th root of 243, I believe that's also 3, and then 3 squared is 9. So I got to multiply 27 times 3 times 9, or 27 times 27, you got 729, but remember the formula I gave you, length times width times height, all divided by 3, so that was a step missed to get a final answer of 243. And then the very last one was to simplify this. So using the quotient property, we can separate the numerator from the denominator. So you knew the denominator came out to be 4, and then for the numerator, we got to find a perfect square that can go into 72. That would be 36. 36 is a perfect square, and it can go into 72 because 36 times 2. So the square root of 36 is 6, and that's all over 4, but then these can be reduced by 2. So 6 divided by 2, let's bring down the square root of 2, 4 divided by 2. So that would have been the final answer for number 10. So those are going over most of them. The only one I didn't do out is number 1, which I sent in the email. If you can just actually try that one again, and I can see your steps. It's just hard on the computer because it doesn't show work. So show me how you did number 1 and we can talk about that. All right, if you still have more questions, let me know.